Hello my dears, welcome to Fatih's Academy of Easy Learning. In this video, we are going to discuss the next topics remaining in our NCERT Physics 10th chapter, light reflection and refraction. Okay, now what we have to discuss is the sign convention for reflection by spherical mirrors. This is what we have to discuss now. For that, let us see there are certain sign conventions called new Cartesian sign conventions which we follows while studying the mirror equation and the mirror image formation, etc. This law should be applied when we deal with the mirrors. The sign conventions or the things which we have to remember is as follows. In this convention, the pole P of the mirror is taken as the origin. Which is taken as the origin? The pole P. What is the pole? Pole is the center of the reflecting surface. And the principal axis of the mirror is taken as the x-axis, x dash, x of the coordinate system. Let's see. Here P is the pole which is the center of this reflecting surface and x dash x is our coordinate. Okay, let's move on to the conventions. The first convention is the object is always placed to the left of the mirror. This implies that the light from the object falls on the mirror from the left hand side. Let's see this picture. The object is always placed on the left of the mirror and the direction of incident light is from the left side only. Okay. Next, all distances parallel to the principal axis are measured from the pole of the mirror. Every distances which are parallel to the principal axis are measured from the pole of the mirror. What that means? The distance is like if we have an object here and we suppose we have the image here. So the image distance and object distance that you have the two new terms. What does that means? Object distance. If it is the object distance, AB is our object, then what is mean by object distance? Object distance is the distance between the pole to the object. And suppose A dash B dash is our image, then we have the image distance like the distance from P to A dash B dash. These two are the two distances which are parallel to the principal axis. That is, what is the second convention means? All distances parallel to the principal axis are measured from the pole of the mirror. The measurement is from uh, pole to the object, pole to image, not from object to pole or image to pole. That is what it means. Next, all the distances measured to the right of the origin along x-axis are taken as positive, while those measured to the left of the origin along negative x-axis are taken as negative. Okay, what is the next point? All the distances which are in the positive direction is taken as positive value, and all the values which are in the negative direction is taken as negative values. Okay, suppose if we have an object here and we have an image here, image in the x direction and object in the x dash direction, then the object distance will be what? Object distance will be negative and the image distance will be a positive value. Okay, next what? The distances measured perpendicular to and above the principal axis are taken as positive y-axis. Distances measured perpendicular to and below the principal axis along negative y-axis is taken as negative. What is the next convention? The object which are in placed above the principal axis, which is and perpendicular, which is actually in the positive y direction, is taken as positive value, and the distances which are perpendicular to the principal axis and which are in the negative y direction is taken as negative values. So what are the conventions? First one is the object is always placed in the left side of the mirror so that the direction of the light is from the left. The second point is that every measurement is done from the pole. Okay, from pole to object, pole to image, not from object to pole or image to pole. And next, what it says, the distances which are measured in the positive x directions are always positive, and the distances which are measured in the negative x directions are always negative. And the next one is the distances in the positive y directions or which are perpendicular and above the principal axis is positive values, and the distances which are perpendicular and below the principal axis are negative values. This is a very simple thing, but you have to remember when you are doing problems, when you are doing your problems and calculations, you have to remember that this conventions. Okay, now what we are going to study is the mirror formula. This is an important formula, mirror formula. What does this mirror formula implies is that mirror formula actually connects the focal length, the object distance u, and the image distance v. In a spherical mirror, the distance of the object from its pole is called the object distance, which is represented by the small letter u. The distance of the image from the pole of the mirror is called the image distance v. We already know that what is focal length f. Then the equation which connects this focal length, the object distance u, and the image distance v is called mirror formula. For all the mirrors, the formula is like 1 by v plus 1 by u is equal to 1 by f. This formula is valid in all situations for all spherical mirrors, for all position of the object, but we have to use the new Cartesian sign convention when we are submitting or substituting numerical values for doing problems. Okay. So what is the mirror formula? Mirror formula is given by 1 by v is equal to 1 by u plus 1 by f. What is meant by 1 by v? Oh, sorry, what is v? V is the distance of the image from the pole. What is u? U is the distance of the object from the pole, and f is the focal length. Okay, when we are doing problems, we have to remember the sign conventions, new Cartesian sign conventions when substituting the values. Okay, what is mean by magnification? Magnification, you have noticed that for the case of certain lenses, for the case of certain mirrors, we can see our images. Sometimes it get enlarged, sometimes it looks smaller, isn't it? Okay, what is mean by magnification? Magnification means how much the image is magnified from the actual size. That value can be calculated using the expression of magnification, which is given by m is equal to height of the image, which is given by h dash divided by height of the object h. Okay, magnification produced by a spherical mirror gives the relative extent to which the image of an object is magnified with respect to the object size. Okay, you have seen the convex lenses, convex mirrors, different kinds of mirrors and everything. Sometimes the objects gets enlarged, sometimes the objects seems to be lesser in its size. This value, that is how much it gets magnified, can be calculated using this expression, which is given by m is equal to height of the image divided by height of the object. Or for the case of mirrors, we have another equation for magnification, which is represented in terms of v and u. What is v? V is the image distance and u is the object distance. Also, magnification m is equal to h dash by h is equal to minus v by u. What is h dash? Height of the image to the height of the object is equal to minus v by u. Okay. You may note that the height of the object is taken to be positive as the object is usually placed above the principal axis. The height of the image should be taken as positive for virtual images. However, it is to be taken as negative for real images. Images are of two types. There are virtual images and there are real images. Virtual images virtual images are formed above the principal axis in the positive y direction, so the height of the image will be positive, whereas in real images the images are formed below the principal axis, that is in the negative y direction. So for the case of real images, the height of the image is negative, and for the case of the virtual images, the height of the image is positive. Okay. A negative sign in the value of the magnification indicates that the image is real. What is meant by the negative sign? Negative sign means the image is real. How it happens? Because minus sign means the image is real. A negative sign in the value of the magnification indicates that the image is real. If suppose you have the magnification m is equal to minus 5, then if you have a question like what kind of images it formed, then what you can say, it is a real image, because what is the reason? The negative value of the magnification means that the image formed is a real image. Okay. A positive sign in the value of the magnification means what? The image is virtual. Let's see an example. Okay. A convex mirror used for rear view on an automobile has a radius of curvature 3 meter. If a bus is located at 5 meter from this mirror, find the position, nature and size of the image. What we have? Okay. Radius of curvature. For the case of convex mirror, the focal length are on the right side of the mirror, isn't it? So the according to the sign conventions, r is equal to plus, object distance u is equal to minus 5. How much is the image distance? Height of the image h dash is equal to how much, that we have to calculate the image distance v and the height of the image. We have focal length f is equal to r by 2. We have r is equal to 3, so f is equal to 1.5. Since 1 by v plus 1 by u is equal to 1 by f, we have 1 by v is equal to 1 by f minus 1 by u. Substituting the values, we will have what? 1 v is equal to plus 1.15 meter. The image is 1.15 meter at the back of the mirror. Okay, what does the plus sign means? It is on the right side of the mirror, which means back of the mirror. Magnification m is equal to h dash by h or minus v by u. Minus v by u means minus 1 by 1.5 meter by 5 meter. The value comes positive. How it comes positive? Since here it is the object distance is minus. This is not only 5 meter. This is minus 5 meter. We have the two minuses get cancelled, and we will have the answer plus 23. Since the magnification is plus value, the image is virtual, erect, and small size in by a factor of 0.23. Okay. If the magnification is greater than 1, the image size is larger than the object. If the magnification is less than 1, the size is lesser than the object. That you have to remember. What two things you have to remember by seeing the magnification. What are the 2 points to be remembered? One is that if the magnification is a positive value, then the image will be a virtual image. If the magnification is a negative value, then you have to remember the image formed is a real image. Okay, and if the value is the magnification value of magnification is less than 1, then you have to remember the size of the image is less than that of the size of the object. And if the magnification is greater than 1, then you have to remember the size of the image is greater than the size of the object. Okay. Next question is, an object 4 centimeter in size, height of the object, this is the 4 centimeter in size means height of the object is given, is placed at 25 centimeter in front of a concave mirror of focal length 15 centimeter. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Find the nature and the size of the image. We have to find the image distance and the nature and size of the image. The object distance is given by 4 centimeter. Object distance is u is equal to minus 25. For the case of concave mirror, it is always whether the mirrors are concave or convex, respective of concave or convex, object distance is always negative. Object distance is always negative. You have to remember one thing, that is for the case of concave mirror, u, v, f, r, 4 values are negative. But for the case of a convex mirror, only U is negative, V, R and F are positive. That I will give you in the last of this chapter as a Word document. Okay, you can have that in a column. What I told you, for the concave mirror, U, V, F, R, 4 quantities are negative. For the case of convex mirror, only U is negative, V, R and F are positive. Okay. Now let's move on to the problem. We have to find V and size of the image H dash. So we have mirror formula, 1 by V is equal to 1 by U plus 1 1 by V is equal 1 by V plus 1 by U is equal to 1 by F, or 1 by V is equal to this plus 1 by U goes to the other side, becomes 1 by F minus 1 by U. Then we have to substitute F is equal to 1 by minus 15. Minus 15 have to be here. The value given is only 15 centimeter, but we have to apply the sign conventions. For the case of concave mirror, it is focal length is negative. So instead of 15 centimeter, we have to write what? Minus 15 centimeter. So 1 by minus 15 centimeter minus 1 by minus 25 will give you what? V is equal to 1 by V is equal to minus 5 plus 3 divided by 75, or V is equal to minus 37.5 centimeter. The screen should be placed at 37.5 centimeter from the mirror. The image is real. How can I have that assumption? Let's see. Magnification M is equal to minus V by U, or H dash is equal to, we have to find the height of the object, height of the image H dash is equal to minus VH by U. So substituting the value, all the values we have, minus 6 centimeter. The image is inverted and enlarged. Inverted means what? It's a it's a real image, isn't it? For the case of real image, the value is negative. For the case of virtual image, the value is positive. So we have the real image, the image is inverted and enlarged. Okay. Here I have included two ray diagrams, one for the laws of reflection. Let's check. We have a reflecting surfaces here, an incident ray which is hit on this reflecting surface is reflected. This is the normal line which is perpendicular to the reflecting surface. We have the angle of incidence which is given by the angle made by the normal and the incident ray, and the angle of reflection is the angle made by the normal and the reflected ray. Angle of incidence is given by I, angle of reflection is given by R. We know by the laws of reflection, the angle of incidence is equal to angle of reflection, and the other things in the second law states that angle of incidence, angle of reflection, the incident ray, reflected ray and normal all are laying in the same plane. One more circuit diagram is here for laws of reflection. Same here the reflecting surface is inclined like this, and we have the incident ray, and the after reflection it passes like this, and this is the normal angle of incidence is this, angle of reflection is this, and you have mirrors. When we told about mirrors, every mirror, whether it is concave or convex, is a part of a sphere. Can you see that? See this? You will be familiar. I was just remind you again. Um, this is a concave mirror. It is a part of a sphere, and C is the center of curvature. What it is? It is the center of the sphere of which this mirror is a part, and P is the pole. Pole is the center of the reflecting surface. We have the radius of curvature, which is the distance between the pole to the center of curvature, and principal axis is what the line which passes through the center of curvature and the pole. Okay, the same for the convex mirror also. For the case of concave mirror, this C lies inside the reflecting surface. For the case of convex mirror, the C lies outside the reflecting surface, and you have the sign conventions of concave mirror and convex mirror in a table. For the case of concave mirror, U, V, F, R, all the four quantities are negative. But for the convex mirror, only U is negative, V, F, and R are positive. That you have to remember. Okay. For the concave mirror, U, V, F, and R are negative. All are negative. For the convex mirror, only U is negative, V, F, and R are positive. Now, in the case of magnification, magnification negative means the image is real. Okay, for the real images, the magnification is real. It will be these details will help you while doing the problem. And what is the peculiarity of real image? Real images are always inverted. And for the case of positive magnification, the image is real, virtual. Virtual images means erect, which are above the principal axis, and the real images which are inverted are below the principal axis. The value of m, if the value of m is less than 1, then size of the image is smaller to size of object. If m is greater than 1, then the size of image will be larger than object. We have already discussed it. I just summarized it in another page. Okay. Thank you. Thank you, dears. If you have any doubts and queries or anything, you can comment. I will uh, try to help you. Okay. Thank you. Thanks for watching my video. Take care.